This is review day 2 going over chapter 12, which is on three-dimensional figures, finding lateral area, surface area, and volume. We're going to go over the formulas that you use for a cylinder, cone, and sphere. In chapter 12, we also covered doing prisms as well as cones, we did cones. Prisms as well as pyramids, and we're not going to be doing that in the review. You also won't see those on the final. I just chose a few three-dimensional figures that we're going to focus on, and you can expect to see any of these three figures. So a cylinder, 3-cup on a cylinder, looks like this. That would be like getting a can of soda. So we've got, for a cylinder, whatever the base is here, you've also got the base on the top as well. And the lateral area is the part that is made up in between the bases, so it's the part that wraps around the cylinder. So to find the lateral area, we use 2 pi RH, and that's from, if you actually looked at the net looks something like this. So this is the base, top, and then the bottom. This is the lateral portion. So if you're looking for the lateral, it's the height times, and then 2 pi r. Well, 2 pi r comes from the last chapter. We were looking at 2 pi r. That's the circumference. So the reason why it's 2 pi r, this is actually the length around the cylinder. It's equal to the distance around the circle because it's the circumference. So it's the circumference, or 2 pi r, circumference times the height, or 2 pi r times the height. The surface area, we take the lateral area, so whatever you find here, and we have to add the bases. So for the surface area, we've also got the top part and the bottom part. So we need to add 2 times the base area. Capital B always stands for base area, and depending on what shape you're using or what shape you're looking at will determine what formula you use for base area. The base here is a circle, so we want to use the area formula for a circle. The base of a cone is also a circle, so we want to use that as well. But for other shapes like a pyramid or a prism, the shape would not be a circle. The shape would be maybe a triangle or a square or something else. So that would be surface area equals, if you want to write this out, it would be 2 pi RH plus 2 times, and then again, base area, because the base is a circle, we want to do the area of a circle, which is pi r squared. And again, it's 2 pi r squared because we've got the top and the bottom. And then volume is how much three-dimensional space is taken up inside of this figure. So to find the volume, we take the base area, so that's capital B, the area, that's pi r squared, times the height of the cylinder. This is pi r squared times h. You're not doing 2 pi r squared because we just want to know the base times the height. 2 pi r squared accounts for surface area, so that would be if we're looking at the top and the bottom, how much space is taken up two-dimensionally. But here, if we just take the base area multiplied by the height, that'll tell us how much volume there is. And then for a cone, so a cone, also known as an ice cream cone. Don't turn your ice cream cone this way or it'll all fall out. So for a cone, we've got the height of a cone, and then the radius of a cone, and then this side, up the side of a cone, is called the slant height. The net of a cone looks like this. So this is the radius, and then the height, you can't see the height in a two-dimensional drawing because that would be like the cones coming out of the page, but this part is the slant height. So any point same distance from the center is the slant height, right? It's the radius. So lateral area is just this portion here. The lateral area is pi times the radius times the slant height. And more than likely you won't be given the height, the radius, and the slant height for a problem. You have to see that there's a right triangle and solve for one of the sides that are missing. And then surface area for a cone is just like a cylinder, but the difference is a cylinder has 2 of the base. A cone only has 1 base. So we take the lateral area, whatever this portion is, and we have to add the base. But again, we only have 1 of the base. So that's the lateral area, pi RL, plus, and then capital B, the base area, the base of the circle, so that's pi r squared. So it looks kind of similar to a cylinder, but the lateral area is different, and then we only want one of the base because we only have one base for a cone. And then the volume, it's similar to the base area times the height, but because it's a cone, it's actually 1/3 of that volume because it's going up. So the amount of volume at the bottom is very large, but the volume at the top is very tiny. So this would be 1/3, and then the base area, that's pi r squared times the height. Or you can write this as pi r squared h over 3, same thing. And then for a sphere, we don't have lateral area of a sphere, but we can look at the surface area and the volume. So for a sphere, yes, I'm a math teacher, not an artist. For a sphere, the radius is here, and the surface area of a sphere is 4 pi r squared. The volume of a sphere is 4/3 pi r cubed, pi r cubed. Make sure you do cubed because it's 3-dimensional. So these are the formulas we're going to use for the surface area and volume of a sphere. If you flip over this paper, or if you printed it on another page, we're going to look at an example of each of these problems. So number 1, we've got a cone. It says the cone has a height of 12 centimeters. So this height, h, is 12 centimeters. We have a slant height, so that's up the side of the cone. That's 13 centimeters. We want to label the diagram, so just did that. Find the lateral area, the surface area, and the volume. So to find the lateral area of a cone, looking at your formula sheet, we use pi times r times L. Here we've got pi. We need the radius, and we already have the slant height. So the radius, r, we need to find r. So the height is coming straight up, so that's a 90-degree angle. If this is 12 and 13, then we've got a right triangle formed, and we can use the Pythagorean theorem. So if you do r squared plus 12 squared equals 13 squared, you're going to get r equals 5. This is a Pythagorean triple, if you already know this one, 5, 12, 13. Another common one, most common, is 3, 4, 5. If you double that, 6, 8, 10. You don't have to remember these, it just makes it a little bit quicker than using the Pythagorean theorem. So lateral area, we've got pi times the radius, we found is 5, times the slant height. Make sure that you use the slant height. You're not using the height of the cone, you're using the slant height, so that's 13. So if we do 5 times 13, that is 65 pi. And please do not multiply these out. So all of the problems on here, as well as on Schoology, if you get pi in your answer, just keep it with pi. That's how I've formatted the answers so that there's no rounding issues. So it's 65 pi. No need to put in units. Please don't put in units. The units for lateral area would be centimeters squared because it's area, but just keep it as 65 pi. The surface area of a cone is the lateral area plus 1 of the base area. We already found the lateral area, that's 65 pi. And we have to add the base area. So to find the base area, it's a circle. So the base area of a circle, that's pi r squared. Well, we know the radius is 5, so pi times 5 squared, that's 25 pi. So we're going to take the lateral, 65 pi, add the base area, 25 pi. That comes out to 90 pi, and again, write it as pi when you're entering that on Schoology. And surface area is also centimeters squared. And then to find the volume for a cone, we use 1/3 the base area times the height. So 1/3, we found the base area, so 25 pi. This is why you don't write in pen. 25 pi times, and then the height is 12. So we want to do 1/3 of 25 pi times 12. Keep it in terms of pi, so don't multiply the pi out. Keep it with pi. we want to do 1/3 of 25 times 12. Well, 1/3 of 12 is just 4, so that'd be 4 times 25, 100. Always good to check, make sure that you did the math correctly. 1 divided by 3 times 25 times 12. Yes, that comes out to 100. So the volume is 100 pi, and the units for volume are centimeters cubed. But again, do not input units for these. Number 2 is a cylinder. So for a cylinder, we want to use lateral area is equal to, that's 2 pi r h. First we want to label the diagram. So the radius is 5, the height is 12. And we don't need any more information for a cylinder, just the radius and the height. So we've got 2 pi times the radius, that's 10, times the height, 12. So that comes out to 240 pi. And again, we write that as 240 pi. That's the lateral area. And this would be feet squared. Surface area, we take the lateral area and we add the bases. We've got 2 bases here, so that's 2 times the base area. Now to find the base area, because it's a circle, we use pi r squared, and I made the radius 5 for both of these, so it's going to be the same base area actually. So this would be pi times 5 squared, that's 25 pi, that's our base area. So we take the lateral area, 240 pi, and we want to add 2 times the base area, so that's 2 times 25 pi. So we have 240 pi plus, that's 50 pi, is 290 pi. And then for the volume, we use the base area times the height. It's not 1/3 because it's not a cone. So the base area, again, the base area is just 25 pi. Yes, there's 2 bases for a cylinder, but when we do volume, we just want to use the base. So that's 25 pi times the height, which is 12. 25 times 12 is 300, so that's 300 pi. So to input that, we would be 300 pi, and that's volume is feet cubed, surface area was feet squared. This is number 3. So for number 3, it says given the sphere with a radius of 14 meters, so the radius is 14 meters, we want to find the surface area. The surface area of a sphere is 4 pi r squared. We know the radius already, so this is going to be 4 pi times 14 squared. And following PEMDAS, we need to do 14 squared before we multiply by 4. 14 squared is 196 times 4 pi. 196 times 4 is 784 pi. Our units would be meters squared, but we're not worrying about units. So this is just 784 pi. And then the volume for a sphere, we use 4/3 pi r cubed. Make sure you do cubed. If you do squared, you're going to get it wrong. So this is 4/3 pi, our radius is 14 cubed. So that's 14 to the 3rd power. So do that first. That's 2,744. So we have 4/3 pi times 2,744. And we want to keep this in terms of pi. So we're only going to multiply the numbers, 4/3 times 2,744. So 4/3 times 4/3 times 2,744 is 3,658 point, and then it's 6 repeating. And this is still in terms of pi, so don't forget the pi, pi. But in terms of entering this for Schoology, it'll say, if it comes out to something like this where the number keeps going, it'll say round to something. So for example, if I said round to the nearest 10th, then you'd say this is the 10th place, so 3, 6, 5, 8 point, If it's 0.6 repeating, then that 6 is going to round this up to a 7. So 3,658.7, and that's pi. This would be our volume. Units are meters cubed. So thanks for watching. Let me know if you have any questions, and hope the homework goes well.